Okay, so this is the last question. It's a long question. It's an exponential question or function question. So we'll give it a go and see how we get on. The relationship between the number of bacteria in a petri dish BT and the time elapsed T is given by the formula B of T equals AE B to the T, where A and B are elements of R. At the time when T is equal to 0, 100 bacteria are placed in a favourable growth medium. 6 hours later, 450 bacteria are present. Show that BT can be represented by B of T is equal to 100 e to the 0.25068 T. So again, a lot of these questions come up in the same way. You must get use your initial value, if you like, to sub that in to get your variable here, and then you use the other value that's given to you in order to get your second variable, which is your B. Okay, so again, it's a lot of the time it's the same exact method. So we write down our function first of all. B of T is equal to A, E, B to the T. The other thing, if you're confused about, is T is obviously hours or time in hours, and then your B of T, your whole B of T, that's again the number of bacteria. Bacteria number if you want. Okay, so again, it just means that you're putting things in the right place, at least in your formula. So the first piece of information I'm going to use, girls, is B of T at T equal to 0, 100 bacteria. So 100 is equal to A, E, B by 0. 100 is equal to A, and again, anything to the power of 0 is just 1. So A then is equal to 100. Now, I use this information then in my second part. So B of T is equal to 100 e to the B T. Okay, and then the second says 6 hours later, 450 bacteria are present. So my number of bacteria is now 450. I have 100 there. E is just exponential. B, I don't know what it is, but I do know that T is 6. Okay, so I divide across by 100 first of all. 450 divided by 100 is equal to EB by 6. That then on the left hand side, I have my variable, or the number I don't know in my power, so that means I must use logs. So log to base E of 450 over 100 is equal to 6b, and then to get b on its own, it's just log to base E of 450 over 100 all over 6. So then just to get my b. So again, just to show you how it's done in the calculator, so log to base E, which is just ln, of 450 over 100 equals, and then divide your answer by 6. So it's 0.250679, and then b is equal to, as we said in the formula, 0.25068. So that's the formula there. So A is equal to 100 and B is equal to 0.25068. How many bacteria will be present after 10 hours? So I'm now going to fill in both of those into my formula. So my formula was BT is equal to A E B to the T. My formula is now B to the T equals 100 E 0.25068 by how many hours? 10 hours. So that's where I'm putting my 10. And again, can I just please reiterate, you don't actually need part A to do part B at all. You just fill it in if you see 10 hours, so you know that's going in for T. They've given you the answer there already in the question, so you don't actually need to get part 1 right. So please don't ever give up. Just try it, input the numbers, okay? And again, you just literally B to the T, you're using your calculator there, or B of T, excuse me. You're just using your calculator there. So it's 1,226.561722 which is approximately 1226.56. Okay. How long will it take for 15,000 bacteria to be present? So I'm just looking for the number of bacteria. So again, write down your formula. B of T is equal to 100 to base E of 0.25068 T. Number of bacteria, so I'm putting 15,000 in this side, equals 100 to base E of 0.25068 T. Again, first protocol is always divide across. And again, I notice that my variable is in my power. That would mean that I need to use logs. So log to base E of 15,000 over 100 is equal to 0.25068 T. And then just to get T on its own, it's log to base E of 15,000 over 100. Divide by 0.25068. So that's T is equal to 19.988, and it said give your answer correct to the nearest hour. So T is equal to 20 hours. We're then on to the drawing part of the question. And again, can I please reiterate, you do not have to have any part of this question right in order to get this graph right. So it's really important with exponential questions, they're not always intricately linked. So please attempt every single part. All you need to draw a graph really, ideally 2 points. If you have more, great, but other than that, no, you don't need it. So I'm going to go back to the original question where it says at T equal to 0, 100 bacteria were present, and at 6 hours, 450 bacteria were present. So just using that information, so at 0, 100 were present, at 6 hours, 450 were present. I know it's an exponential graph, it has a positive power, so that would mean it's a positive exponential graph, and just by literally doing that and by using 2 points, I have a pretty decent graph. Now, of course, you can make it more accurate if you would like by using other numbers. For example, 10 hours was 1,226. If you want to fill in 4 hours, if you want to fill in 2 hours, you can get a much more accurate answer. But to be honest, that's pretty good by just using 2 points. And then the last one says, from your graph, estimate the number of bacteria present after 3.5 hours. So this is 3, so then 3.5 hours. Again, if it says use your graph or from your graph, use your dotted line on the graph. And again, if that's 200, that's 250, that's 225. And again, kind of halfway up there in between, if we say approximately 230 roughly, that shouldn't be bad. Approx 230 to kind of even I suppose it could be a little bit more accurate, but 230, and again they usually give plus or minus, so kind of 230 to 232, and then it's usually plus or minus 10 there, but again just make sure you do the dotted line drawn in, girls. And that's it.